of the slopes. The only thing that's goofing you up now is the arithmetic of the seconds. That's the only thing that's giving you guys agita now. That's it. Everything else is perfect. Everything else is perfect. So let's real quickly, and this is the kind of thing you guys can figure out. I mean, you don't need to sit here in class and learn. It's the kind of thing you'll make peace with in time. And Usain Bolt's problem on the exam next week will totally make you make peace with it. So let's crank the next. I think it's E, F, and G, and H, right? So we did up to, it looks like 1 second before, yes? Now you guys are working independently. The next one is, how about my average rate of change from a half second before? So we grab this, and you know, slide it forward a bit smaller. You know that this 1 is going to become a 0.5, yes? Okay. Yeah, that's really good. 0.5. Now, is that 10.1 change out front? Never, because that's your reference point. You're ending at that time of 10.1 comma 200. The 9.1 has to change, doesn't it? What time is half a second before 10.1? 9.6. So this guy out here has to become 9.6, yes? That's a half second before 10.1. Press enter. That, I'm going 35.1 feet per second. Yep. Notice it's faster. It is faster. But it's less of an exaggeration than the ones before it. And you're going to notice that as we keep getting closer and closer and closer, they're going to keep getting faster and faster and faster. Because geometrically, I'm going to put the graph back up right before we end today. Geometrically, what's happening is it's starting to zoom out like this. It's starting to zoom in, actually. It's becoming very close. The 2 points are almost on top of each other. And that was the point of the next 3. Because I think that it was a 10, 100, and 1,000. Close, right? So let's do each of those. Let me get clear first. There we go. So a 10 is 0.1. So your denominator is now 0.1. Your numerator is still a 10.1, but what is the second, a tenth of a second before 10.1? It was kind of a trick question. I apologize for that. It's 10. It's 10 even. So 1, 0, and then delete to get rid of that extra little 1 that was over there. Press enter. Does this make sense? I think it does. 35.8 is faster. It's faster. Oops. 10.1. Or excuse me, 10 to 10.1. What marker is this? Full of markers. 35.8. Faster again, but again, not as fast as the one previous. Okay. Next up, 100th of a second before, yes? 100th. So second, enter. This becomes 0.01. This was probably the trickiest one to wrap your mind around as far as what number has to go in that second spot. So 10.1, what is this guy going to have to be? 10.09. That was, you have to think about that. There's a couple ways you can do it. You can actually do 10.1 minus 0.01 and see what it is. Or just realize if you make it 10.09, if you add 100th to that, 0.1, the 1 is going to become a 0, carry the 1 over, and that becomes a 1, then you're at 10.1. So there's your 100th of a second behind it. How fast was I going? 35.9. Didn't change a whole lot at all, did it? Didn't change a whole lot at all. Nor did it change a whole lot at all when it was 1,000th of a second before, did it? Keep it going. This is going to become 10.009 divided by 0. See the beauty of doing this with the second enter? I mean, my God, imagine doing this all by hand. This is why we invented computers. That's why they're called computers. Just like to compute. So here we go. Oh, Jacob, go.
We hit enter really quick. Actually.
Yeah.
See, that's what I was seeing. It's gonna be.
Because you missed one of your parentheses.
I did, didn't I?
Yeah.
No, it's.
No, I didn't.
099, not 009.
99, not 009. Thank you. I forgot to carry my 1. Thank you, Jake. Boom. There we go. Thank you. I was helping you guys correctly at your desks and I did it wrong up here. Thank you very much. No, you guys are perfect. So, but now look, 35.92. It's a little faster than 35.91. But not much faster. And that the last question of the quiz is, how much different are your previous 3 numbers?
Not really.
Not a whole lot, right? So now, the policeman's hairdryer, when they're pointing that thing at your car, they're taking 2 very quick maybe 1,000th of a second apart. So what do you think? What do you think? Is that a pretty good indicator of how fast I'm going right there at that moment at 10.1 seconds? It is. If you want to make it more precise, you can go and throw some more zeros and nines on there. For example, you can put a couple more nines if you want, and then a couple more zeros here if you want. But look, are you picking up that much more precision in the speed? Yeah, it's a little faster, but it's still 35.93 versus 35.93. I mean, you're not really picking up anything. So I think I'm going about 35.9 miles or feet per second, which is how many miles per hour. Now, Tom, who just left, wanted to share a bit of wisdom with you, which I think is fantastic. 88 feet per second is 60 miles an hour. That's kind of a neat thing to keep track in your mind. When you're on the highway, for example, and you're traveling 60, realize that every second that passes, you're going 88 feet. So we can get a ballpark of how fast I'm going by kind of working backwards from that. If I cut 88 in half, I get 44. 44 feet per second would be 30 miles an hour. So I'm obviously not going 30 miles an hour. I'm going less than 30 miles an hour, yes? Because this is below 44. So now the question is, how fast am I actually going? Your entire next project due in week 6 is devoted to this. I want to use Google, though, really quickly to show you how you can get these answers very, very rapidly using Google. So let me slide over here. This will be the last thing we do today.